Today's objective is similar and congruent figures. When we're talking about figures, we're in geometry. So congruent means equal in geometry. I don't know why we don't say equals, but we don't. We just say congruent. The shapes are the same size and the same shape. So they're identical, they're equal. Similar means same shape, but different size. So these two triangles would be congruent, and the symbol for congruent is an equal sign with a squiggle on top. And you can tell they're congruent because these right angles are the same. This angle has one curvy line. The bottom angle, these both have two curvy lines. Those are saying these are the same. And the sides, 1, 1, 2, 2, 3, 3. And the straight lines are called hash marks. So I could either write all these symbols on it to show that they're congruent, or I could write the equal sign with a curvy line on top. Similar is the same shape but different sizes, and the symbol for similar is just the curvy line, okay? So this is equals, that's why it has the equal sign. So these are the same shape, and the angles are the same, but the sides are different. So I wrote the angles in similar figures have the same measurements. The sides have different lengths, however, they are proportional, and we're going to do some work to show that. So here are two trapezoids, and I am telling you trapezoid ABCD is similar to trapezoid EFGH. And when you see the letters like that, what you need to do, sorry my nose is itching, what you need to do is go compare so you know what sides are what, because as you can tell by looking at this, these are not oriented, pointed the same direction. So A, B, C, D, E, F, G, H. So that tells you that this side here, AB, is proportional to this side here, EF. Okay, see what I mean? A, B, C, D, E, F, G, H. All right, so we need to find the ratio of the lengths, then side X and side Y. Side X and side Y. So for the ratio of the lengths, you pick a side and the corresponding side from the other shape. So I said AB, and I saw that it's corresponds to EF. So I'm going to say AB over EF. Now the measurement, 12 over 8. 12 over 8. And simplify it, 3 over 2. So what that tells you is the ratio of the lengths is that if this side is 3, this side will be 2. This is 1.5 times bigger than this one is. That's 3 halves, 1.5 times. Tells you the first one is 1.5 times bigger than the second. That's just part of your homework, so I showed you how to do that. All right, now we need to find sides X and Y. So you write a ratio from the shape with all of the measurements and compare it to the missing side. So for X, I'm going to, here's X. Okay, so X is across from 8. 12 is across from 12. So I'm just going to pick these two. I'm going to say 12 over 12 equals 8 over X. I know you know what the answer is. 12 over 12 equals 8 over X. So what is X? 8, because these two side measurements are the same. You could actually just tell that by looking. And for Y, here's Y. So, and it's on the bottom. So I'm going to compare the top and the bottom. BC is the same as FG. And you can tell that because the middle two numbers BC and FG, those are the same sides. So I'm going to say 3 is to 6 as 2 is to Y. 3 is to 6 and 2 is to Y. And I said Y equals 4. And I saw the relationship, so I didn't do cross multiplying. Okay, but I always could do cross multiplying. All right, now let's do a little bit of work. Here I have triangle ABC is similar to triangle DEF. So let's look. ABC DEF. Okay, so that looks a little funny, but that's how they are. So that means that this side here, AB, is corresponds to this side here, DE. So list the corresponding sides and angles. You can do this straight from the little code you're given up here. You don't even have to look at the triangles. the first one is the same as the first one, the second one is the same as the second one, the third one is the same as the third one for your angles. So you make the angle symbol, it's kind of like a less than symbol, but the bottom is straight on the line. So angle A and angle D, because they're the first ones, comma, angle B and angle E, because they're the middle ones, and then angles C and F. Those are the corresponding angles, okay? And the corresponding sides, side AB goes with side DE. So this side and this side, okay? And then BC goes with EF. BC goes with EF. And then the last one's AB goes with DF. So we just kind of group them in the twos. The first two, the last two, and then the first and last. So I can write that by saying AB, line segment, and DE, BC, and EF, and then AC and DF. Okay, and I did that all from looking at the little code that I'm given. I didn't even bother looking at the triangles because those are confusing sometimes. All right, number 2, find the missing angle in angle ABC. Triangle ABC. Here's triangle ABC. Well, all triangles have an interior angle measurement of 180 degrees because they're always half of a square. And you know that in a square, each of these angles is 90 degrees, and there's 4 90-degree angles. So that means a square is 360 degrees, and a triangle is half of that. So if I take away half of it, just have this bottom half, that's the same as divide this by 2, so it's 180 degrees for every single triangle. So I can add up the degrees that I have and subtract that from 180. 72 plus 31, 70 plus 30 is 100, 2 plus 1 is 3. So I would say 180 minus 103 equals, well, if it was 180 minus 100, it would be 80, but I need to minus 3 more, so that would be 77 degrees. Okay? Now, list the measures for angles D, E, and F. Well, in similar triangles, the angle measurements are the same. So angle A is the same as angle D. We just found angle A, so it's the same as D. So that would be 77. E is the same as B, and B is 72. And F is the same as C, and C is 31. So that's all you have to do. You don't have to do any math. It's just figuring out which corresponds with which. Okay? All right. Last one. Here are 2 parallelograms, although they don't look like parallelograms. They're supposed to be parallelograms. And I am saying that LMNO is similar to PQRS. So LMNO is similar to PQRS. Okay? So that means PQ is the same as LM. All right. Find the measure of angle M and the measure of angle P. Well, the measure of angle M, how did I mess that up? I didn't mean to write that. I meant to write, oh, sorry. I keep thinking this. The measure of angle L, sorry, I didn't make a mistake, is the same as P, okay? Because those go together. So we know that L is 132. So M is the same as, what did I do here? Measure of angle M. Oh, M is the same as Q. Well, let's do measure P first. I'm sorry, I wrote this backwards. Sorry. P is the same as L. So P is the same as L. So it's going to be 132. And M is the same as Q. See, M and Q are the same. And Q is 97, so that means M is going to be 97. Sorry, had it all organized, then I did it backwards. All right, number 2, find the length of segment RS. All right, RS is going to be the same as NO. Do I have NO? No, I'm sorry, it's not the same, but it's proportional. All right, NO is 14. So here I have the top and the bottom And here I just have the top. I don't have the bottom. So I set up a proportion, and this is the one that I need to find. So I'm going to say 7 is to 14 as 9 is to x. See relationship? Hope you do. X equals 18 because it's just half. Lastly, find line MN. Okay, MN is the same as QR. I know what QR is. QR is 6. So now I'm going to say top is to side as top is to side. We'll say that's Y. So I'm going to say 9 is to 6 as 7 is to Y. You just need to do it the same way. I could write a word ratio on this, but I just said it. I said top is to side as top is to side. Okay? Now I could simplify, divide by 3 and get 3 over 2. Now I'm going to have to multiply. So 3y equals 14. So y equals 14 over 3, which equals, how many times does 3 go into 14? 4. How many left over? 2/3. So that's the length. Okay, MN is 4 2/3. And that's it.